So we start by talking about variance of a geometric random variable. So the first thing you note is that for a geometric random variable, probability that the random variable x takes on, say, value I, this is given as 1 minus p to the power of I minus 1, and then you multiply it with p, where p is the probability of success. So instead of 1 minus p, we are going to write r now. So expectation of x square would be I square times r to the power of I minus 1 times p. So this is nothing but probability that x takes on value I, and then you multiply it with I square because you have x square here. So instead of I, you can write I minus 1 plus 1, because this minus 1 and plus 1 cancel out, you square it. So now you expand it, you get I minus 1 square plus 2I minus 1 plus 1. Now instead of I minus 1, you substitute j. So when I is 1, j would be 0, and when j is infinity, I will also be infinity. So for I is 1, j is 0. So that's why you have j is equal to 0 here, j is 0 here, and j is 0 here. So we have done nothing, we have just put j here. So you have j square here, then you have 2j here, and you have 1 here. So that is what we have simply done. Now for the first thing, you take r outside. So if you take r outside, this expression here, this simply becomes r times summation of j equals to 0 to infinity j square times r to the power of j minus 1 times p. So r to the power of j minus 1 times p, this is nothing but again a geometric random variable. So this will be expectation of x square. So instead of j, you could have written I here. So that does not matter. So this is almost the same or exactly the same as this one, because j equals to 0 does not matter. You put in 0, then you get multiplied by 0, so it does not matter. So instead of j, you could have written I, so you could have changed index. So this is same as expectation of x square. So this part is same as this entire part right here, because j equal to 0 does not matter. So you have expectation of x square right here. Then you take r common outside here for the second expression. You can write it as 2r times summation again j equals to 0 to infinity, and you have taken r outside, so you have j times r to the power of j minus 1 times p. So r to the power of j minus 1 is nothing but 1 minus p to the power of j minus 1. So again it is j times probability. So j times probability that x is equal to j, and this is just j here and j here. So this is this means that this is expectation of the random variable x. And finally you can take this p common outside, and we are focusing on this third term. So you can notice that summation of j equals to 0 to infinity rg, and p is outside. So if you sum this up, this is a geometric series. This will become p times 1 over 1 minus r. This 1 over 1 minus r is the sum of this geometric series. But 1 minus r is just p. So from this expression you can also see that p is equal to 1 minus r. So this becomes p times 1 by p, which is 1. And that's how you get 1 here. Now expectation of the random variable x is 1 by p. Yeah, for a geometric random variable, this we have computed before. So for a geometric random variable x, expectation of x is 1 by p. So that is pretty much it. You plug this 1 by p here, and what you get is, so you finally get expectation of x square is equal to r times expectation of x square plus 2r times expectation of x plus 1. So I'm going to take this term this side, you get 1 minus r times expectation of x square. Now 1 minus r is just p. So you can see 1 minus r is just p. So p times expectation of x square is equal to 2r divided by p plus 1. So this is 2r by p plus 1. Now you divide both sides by p, so you get expectation of x square comes out to be r plus 1 by p square. So expectation of x square is equal to r plus 1 by p square. So what is variance of x? Variance of x is expectation of x square minus expectation of x squared. So expectation of x square we just found out here. So we should have a equal to sign here. So expectation of x square is r plus 1 by p square. So that's what you have plugged it in. Minus expectation of x square, that is 1 by p square. So this is, you get as r by p square. R is nothing but 1 minus p, and you get variance of x as 1 minus p over p square. So notice we have not focused much on the computation here, but let us do it. So this will give you expectation of x square is nothing but 2r plus p by p square. So instead of 2r, you can write 2 minus 2p plus p over p square. So that will be 2 minus p over p square. But 2 minus p you can rewrite as 1 plus 1 minus p over p square. And 1 minus p you can again rewrite as r. So that is how you get r plus 1 over p square here. So that is the variance of the geometric random variable x.